Hello friends, welcome back to the fifth session of AWS networking. In this session, we are going to cover the AWS route table and NACL, which is called the Network Access Control List. So far we have covered some other basic concepts of the AWS networking like the VPC and then Internet Gateway, NAT Gateway, security groups. Okay. So in this session, we are going to cover the route table and NACL. So before that one, okay, let me give you a quick recap what we have learned in the previous session about the security groups by drawing an architecture, and then I will continue on the route table and NACL. Right. So now let me draw. Let's suppose this is my VPC. This is my personal VPC in the AWS cloud. Okay, and suppose that this is the internet, right? And then if someone is trying to access the application from the internet, then what we need the internet gateway, right? So this is the single point of contact for every traffic which is coming in and out from the public network, or you can say from the internet in your personal VPC in the AWS. For that you need the internet gateway, right? Now from the internet gateway inside we have a multiple subnet, right? We have a public subnet and private subnet, correct? And for the internet gateway, the traffic which is coming from the internet, okay, for that we have the public subnet. We have public subnet. So that means the request from the internet gateway will always come to your public subnet, not to your private subnet, right? Because this is my private subnet, and we do not allow the traffic from the public network or from the internet to our private subnet directly, right? This is what we have learned. And if you need the private subnet to access the internet in one direction from inside to outside, what we have learned, for that we need the NAT gateway. Okay, this NAT gateway specifically for a private subnet. If your any of the software or application need to reach the internet, so it will go from the NAT gateway. So NAT gateway will be targeted, configured with the internet gateway, and then traffic will go outside. So this is we have learned about the internet gateway, NAT gateway, your public subnet, and private subnet and public subnet. Right. Now, in the previous session, we have learned about the security groups. And security groups specifically what we have learned, this is at the instance level. For example, in this public subnet, I have my virtual machine. Okay. So the traffic which is coming in and out from my virtual machine, for that I can define the security group. Right. So that means this security group is to restrict the traffic at the instance level inside a subnet. Right. This is the instance level. Now, the route table and NACL, this is something which is to restrict the traffic at the VPC level and at the subnet level. Okay. So let me repeat that what I'm saying. In the security groups, what we have learned, security group is used to restrict the traffic at the resource level. For example, at the virtual machine level, the traffic which is coming in and going out from my virtual machine, that I can control with the help of security groups, right? But now to control the traffic which is coming in and going out from my VPC, because this is the very first layer, right? The because VPC is your private cloud, so the very first boundary of your virtual cloud is your VPC. That means you restrict the traffic at the VPC level. And second, once the traffic reach from VPC inside, before reaching your resources, it is going to reach to your subnet. Correct. So that means to restrict the traffic at the VPC level and at the subnet level, we use route table and the network access control list. Okay. So basically, this route table is to configure at the VPC level. Okay. To define the route where the traffic can go out or can in as well. Okay. And NACL is something at the subnet level. Okay. Like from where traffic go and in and out from a particular subnet. This is the very basic difference between route table and subnet. Now, how we define that rule, and there are few other important things are also there that we need to learn. Okay, and let me tell you that as well. What I'm talking about, the complete flow, how it works. okay, in the VPC. Now I'm going to draw again. This is the VPC. Okay, so this is my VPC. Okay, and here I have the internet gateway. This is the public network. Okay, and here I have my one of my subnet. This is my subnet, right? And now what I said, at the VPC level, we define the route table. Okay, this route table is specifically to configure where the traffic can go out. Okay, this is applicable for in traffic as well. But basically what I am saying here, route table basically define where the traffic can go from your VPC. Okay, for example, the source and target, like if I'm saying this is the my VPC, okay, from my VPC the traffic can go to the public network, to internet, right? So for that I need this internet gateway. Second, the traffic can go to the outside via NAT gateway. We may have the VPC peering. That means the traffic is going between two different VPCs, right? Similarly, we have the virtual private gateway, and then we have a transit gateway where multiple other gateways are there. So that means, for example, from your VPC, your traffic can go to the different destinations, right? So to define these kind of a destinations, we define the rules in the route table. So for internet gateway, what is the format of rule? 0.0.0.0/0, and then mapping with the internet gateway ID. Similarly, if the traffic is going to NAT gateway, the format will be 0.0.0.0/0 and then your NAT gateway ID. Similarly, it will be the ID of the different gateway. So this is the way how you define the route. And along with that, okay, we have multiple subnet inside the same VPC, right? We may have a multiple subnet, and we want to allow the communication between the different subnet, and for that there is a default rule is automatically added, and that rule is the CIDR of your VPC, okay, and the mapping is local. So the CIDR of your VPC and local rule is to define or allow the communication between your subnet, and to allow the other traffic like to traffic to internet gateway, which is going to internet. If you have a configured NAT gateway, if you have configured the VPC peering, VPC other transit gateway or other gateways, so for that you can define the corresponding routes like this one. So this 0.0.0.0/0 means anywhere. Okay, so that means, for example, if you are sending the traffic outside your internet via your internet gateway, okay, so from internet gateway it can traffic can go to anywhere, right? Similarly, if the traffic is from your VPC going to NAT gateway, from NAT gateway it can go to anywhere on the internet, right? So this is the rule that we define with the help of 0.0.0.0/0. So this is the way how we define the route in the your route table. Okay, so let me quickly show it again. 0.0.0.0/0 and mapping with the internet gateway. This is the route table rule. One rule for allowing the communication between the different subnets in the same VPC. The rule will be CIDR of your VPC, which is covering all the IP addresses, and then local. So this is route table 2. So this is to allow the communication between all subnet in your VPC. Similarly, if you have configured the NAT gateway, then routing in the your routing table will be here. You will have a NAT gateway ID, right? And similarly, if you have with the VPC peering, then VPC peering ID. If you are going with the transit gateway, then transit gateway ID. If you are going with the virtual private gateway, then virtual private gateway ID. So by this way, we can define the routes, okay, in your VPC, right? So this is all about route. Now, what is the NACL? Okay, now let me tell you about the NACL as well. So what I said about the NACL, this NACL is restrict the traffic at the subnet level, right? So this is my subnet. This is my public subnet where I have two virtual machines, VM1, VM. 2, and here I may have the security groups which is restricting the traffic inside the VM level. Now the traffic which is reaching to my subnet, which is going inside my subnet. So here at this level, I can define the restriction at the NACL, network access control list. Okay. So here again in NACL, just like the security groups, we have the inbound and outbound rules. Okay, that we can define to allow the traffic can go and in and out from my subnet. Right. So the difference what we have learned here about the security group and NACL. Security group is restrict the traffic at the resource level inside a subnet, for example, virtual machine. And NACL is restrict the traffic at the subnet level. Right. So now suppose that you have one web server is running here on port 80. Okay. So even in the security group, you are allowing the traffic for the port 80 in the VM, but if you have restricted the port 80 at the NACL level here, you have restricted port 80, then your VM will not able to, or any of the services will not able to reach on port 80, which is running on this particular virtual machine. Even you have allowed the in traffic on port 80 because you have restrict the traffic at the subnet level. So it's very simple. NACL is restricting the traffic at my subnet level. Security groups are restricting the traffic at my instance level. Okay, so this is the difference between, in a nutshell, about the route table, NACL, and security groups. Routing table restricting at the VPC level, NACL restricting at the subnet level, security group restricting at the instance level, which we have configured inside the subnet. Okay, so this is the main difference between route table, NACL, and security groups. Okay, and let me tell you about the inflow as well. Suppose that some request is coming from outside to inside. Okay, so what we have discussed so far about the route table, whatever the rule that we have discussed, which is the traffic which is going out from the VPC. Right. Now suppose if for the traffic which is coming into your VPC from the internet, the first contact is internet gateway. Right. So that means in the route table, you should need a rule 0.0.0.0/0 mapping to internet gateway ID. This is the very first rule that you need in your route table for the traffic which is coming from the internet to allow that one. This is the first rule. Second rule, second restrictions, we have the NACL at the subnet level. Right. So in subnet level, you need to define the inbound for a particular port, okay, or for a range. For example, if someone trying to access the services which is running on port 80, so you need to allow the inbound on port 80 at the NACL level. And once the traffic is in from the NACL, then you need to allow in the security group at the VM level as well on the port 80. Okay, and then only a user can able to access the services which is running on the VM. One, it is passed from the routing table, and then it is passed from the NACL, and then it has to pass from the security group. So these are the three security levels it has to pass before it can reach to the services which is running inside your virtual machine. And one important difference between your NACL and security group is your security group is stateful and NACL is stateless. It's very simple. That means if whatever the traffic which is coming into your subnet from the NACL, for that you have to define the corresponding out rule as well. Okay, that means if someone is accessing the port 80 and you have defined the inbound rule, then you have to define the same for the outbound rule as well. Okay, this is called a stateless. But when we talk about the security group, which is stateful, that means if you have allowed the in communication, for example, on port 80, then you don't need to define the outbound. The same communication, or you can say the response, will be handed over the same route or the same connection which has allowed the in. Okay, so this is the important difference between NACL and security groups, where NACL is the stateless and security groups are the stateful. Right. So now hope you are clear on what exactly is the NACL and the security groups and specifically the routing and how the traffic communicate in and out from the VPC and from the subnet and the instance level in the AWS.